Kelly with a link.
What was that?
That's Kelly trying to get me again. Let's see if I do Control C, close, and just email Kelly. Hello. Doing the Metric Olympics, but we're having technical difficulties.
Oh, okay.
I don't know. Could be somebody out on the internet watching us. Tilt this so they can see us.
That widget, like, not even good.
Are these the discus?
Those are the discs.
We're probably showing the hallway for this one.
Yeah, we can go outside, but we don't want to throw too far, because then you got to measure it. 2 KCD.
We have like those giant 100-foot tape measures. I'm sure we can manage.
Yeah, we can measure anything. Okay, let's see if we got Kelly in here yet. Oh, there she is. Hi, Kelly.
That's
Okay,
weird.
So let's move this chair on here.
Hi.
Even cooler.
Hi, Kelly. All right, I'm going to demo what we're doing.
And it's a big pulsating head thing going on. That's awesome.
Should I tilt it down? Should I tilt it down?
We'll check it out in a minute. So let's see, Kelly, did you get a hold of the materials online? Share
I
my
printed out the
screen here.
worksheets.
Oops, share. Okay, and oops, I broke my speaker. Hang
4
on.
meters.
Oh, yes, you got them. Good, 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 good.
10
Why is
10
my
centimeters,
speaker
so 410.
All right.
Setting
You go speaker off.
communication. Let's turn the Yamaha on. Save. Is my microphone working? Looks like it.
Literally says microphone off right there.
And that's how you turn it off. It says it's on down here, so I think I'm good. Okay, so let's see, we've got the Metric Olympics. So the Metric Me worksheet will just help you understand better the Metric Olympics to help you get used to metric measurements if you're not used to them. So for example, you already fill that out?
I have my height.
My speaker's still not working, hang on.
I have how
Why?
tall
Oops,
I am.
muted it. Ah, there we go. Okay. What did you say about filling it out?
I have how tall I am.
Oh, good. Okay. So eventually you want to try and fill out the rest of this. And
Okay.
some things that we went over that might be helpful. Let's get a new page. The magic pen. Where's the magic pen?
You have 2, you have 1 right there. Your other one's right
Let's
there.
see, does this pen work? Nope. Try that one. Let's try this magic pen. That one doesn't work either. It's gonna be one of those days, Kelly. I got nothing that works. Okay. So I will type stuff in a spreadsheet. Hang on. Let's see, what was this recording? Oh, this was probability. Sorry about that. We have to clean up my desktop. Okay. So I need a spreadsheet. Here we go. New sheet. All right. So if we're going to talk about, say, Celsius versus Fahrenheit. Celsius, water freezes at 0. Fahrenheit, it's 32. That's a helpful one to know. And what else is good to know? How about human body? Oh, room temperature is about 22 Celsius, or that would be exactly 71.6 degrees Fahrenheit. And then human body temperature is 37 Celsius, or 98.6 degrees Fahrenheit. Oops, human body. No, leave it there. And then 100. Oh yeah, you can erase that part. 100 degrees Celsius is 212 degrees Fahrenheit, and that's where water boils. So those are some good. Oh, Debbie's there. Hi, Debbie.
Hello.
So over here, we're doing the Metric Olympics. Did you get a chance to look at what I posted on the course website?
Yeah, I looked through it a little bit.
Okay. So the things that need to happen is the metric Olympics is easier if you first do some practice metric stuff, like measure your height in centimeters and meters, measure your hand span, how wide is your thumb, and then play with a couple of different things. Like your height, you could play with centimeters or meters. Your thumb, you could do
Like we
centimeters.
did Wednesday?
In Wednesday, we did some of those in class Wednesday, correct. So here I'm just asking you to do some more measurements to try and get used to the metric system. And then once you get all this stuff filled out, then it's time to start playing the metric Olympics. Now, some of these events you might not be able to do at home. You might have to do a scavenger hunt over the next couple of days. For example, do you have a measuring device at home that measures in milliliters?
Can I borrow something on Tuesday?
Yeah, totally. Like I have a measuring cup at home that's metric on one side and plain regular on the other.
Just before I roll it up.
What's
Oh,
that?
I might have like a liquid measuring cup.
Yeah. So one of the events here is the one-handed sponge squeeze, where you take a damp sponge and you squeeze it into a cup and guess how many milliliters it is, and then you pour it into something that can tell you the answer, like a measuring cup that has milliliters on it.
Okay.
Other thing is the heat trials might be hard to do because most people don't have a thermometer at home that measures Celsius. But
Right.
if you do have one, you could do the heat trials. So the way the heat trials work is you take some cold water in one glass and some pretty warm water in another glass, and you stick your hand in and try to guess what the temperature is in Celsius. Then you use the thermometer to try and measure it.
Okay.
Let's see, what the other hard one to do at home is most people don't have scales at home that measure in grams. So the one-handed grab would be hard to do for most people at home because they don't have a gram measurer. So if you can't find one, then skip the event and just say like not applicable because you couldn't find it a bit quick. But it could be your school might have something that measures that.
Okay.
Scale around, so you could check. And so what we do here is I have a bucket of marbles, and we reach into the bucket and we pull out a handful of marbles and we try to guess how many grams are in our hand. Before we did that, I passed around the room some weights in the metric system. So let me turn my camera on. I can show you a couple things I did here. Let's see, how do I do that? Hit that button. Nope. That one. And oh, there's my camera. Hello. So let's see. Oh yeah, can you give me the water bottle? All right. So I used to get these water bottles at Albertsons. Albertsons doesn't exist in Pendleton anymore, but most stores you can get a liter water bottle, and a liter of water happens to be a kilogram, which is kind of cool. So that's something you can get your hands on that weighs a kilogram. Often you can look at liquid measuring things, and they'll say across the bottom that it's this many quarts or this many liters. So you can kind of get a feel for quarts versus liters or ounces versus milliliters.
Okay.
Other common things is like medicine, liquid medicine that you take. They'll often have teaspoon measurements versus milliliter measurements on them. Does anybody, any of the four of you remember like the relationship between milliliters and like a teaspoon?
No.
Is it 10 milliliters?
Almost, yeah, good guess. I think it's about 5 milliliters per teaspoon. There's 3 teaspoons in a tablespoon, so there's like 15 milliliters in a tablespoon. So anything you can get for like a comparison, a lot of people are pretty used to teaspoons and tablespoons. They're used to quarts. But most quart containers of water are actually liter containers of water. And then I had some other metal weights in class, like this bigger one is a kilogram, and this one's a half a kilogram, or 500 grams. A regular big paper clip is about 1 gram. And let's see, I'll show you. And I've got just my marbles here. A marble is going to be around 3, 4, or 5 grams, a regular marble.
Okay.
And with the one-handed marble grab, and that's the other thing, not everybody has marbles just hanging around. So some of these things won't necessarily be doable. But the point is just to kind of play with the metric system, try and get used to it. And that's what these two activities are about. So what I'd like you to do is play around, find any measuring devices that you can in your house or work over the next couple of days, and try and fill out the Here I Am Metrically Speaking sheet.
Okay.
And the mini metric Olympics. Do as many events as you can. And if you can't, find a metric thermometer or a scale that measures in grams, then just don't worry about it. And the way you play the event is, for example, let's have Greg demonstrate the standing long step. Lovely assistant Greg here. Let's see where to go. There he is.
So you start the line.
So we start at a line.
I like to limber it up, stretch it down a little bit. We'll see how far you can step. And then mark where your toe comes to. There. That's from my other one. I'm improving.
Okay, so after you do the event, then what do you do?
We look at it, estimate the distance, and then measure the actual
Yeah,
distance.
measure the distance. So in the end, what we want to do is we want to compare our estimated distance to what we actually measured.
Okay.
And so the way the game works at the end is we look at whoever has the lowest overall difference is the winner of the Metric Olympics.
Oh, nice.
And they get a cool metric prize.
Sounds good.
Like a lovely beaker. Or perhaps a metric measuring tape. Or one of the favorites, a Celsius to Fahrenheit thermometer.
Nice.
Yeah, so last week we talked a little about how to convert. This week we're mainly worried about just measuring.
Okay.
And that's all we're doing today. We spent the last a little over an hour measuring stuff and ourselves and playing with the events. And then we're going to move on to some other stuff on Wednesday, but we'll review the Metric Olympics. So try to do what you can by Wednesday.
Okay.
I think I'll win.
On last Wednesday,
Yeah.
the computer wasn't working or whatever, so I wasn't able to see any of the class.
Oh gosh, that's right. I forgot. I meant to do something like that.
Yeah, that's okay. I just had 2 homework questions.
Yeah.
Did you guys go over homework questions on Wednesday?
We did not.
Oh, you did not. Okay.
So what do you
Is that
have?
Section 8, it's actually probably about this stuff. 11.2, numbers 10 and 11.
There's 10 and 11. Okay, let's take a peek right now. Turn my desktop back on. Okay, and then switch to my math lab homework. What's wrong mode? Homework 11 to 10 11. And the stuff we're doing today fits best in section 11.2. All right, 10. This might have been the one Greg asked about too. Let's see, we should turn the projector.
Yeah, I need to go back and fix that one.
Yes, this is the one. Okay, yeah, we'll go over this. We'll let me get a magic board warmed up.
Because if you actually try to look up the speed of Bob's speed, it's different than what the book says it is. That's the problem if you're actually looking it up like I did.
Oh.
So their mock speed is slightly off compared to our mock, to like real mock speed. They said it was like 344 or something, and it's actually like 341. So if you convert it online, it's not going to work.
Huh.
Okay, so the one,
Well, the point wasn't to convert it online,
well,
but it's an excellent strategy.
when you're stuck and you're trying to figure it out, and you.
Yeah.
So the one-handed grab is the marbles, and we measure how much they weigh.
Yeah, so you guess how what you think the mass is in your hand, and then you weigh them and see what it comes out to be.
Okay, so I calibrated this, and it 30. This little bowl weighs 35
Okay.
grams.
So, okay, so
And these are all grams, Gary. These things, different various grams.
yes, they are. So that's 100, 250.
This one closer to this one. I think this is too much. I think this
Okay.
is too much. 500.
Just a minute while Greg finishes his and Danielle finishes their one-handed marble
I
grab.
think it's closer to this one. I think this has got a 34 gram weight on it already.
That's 34.
Yeah.
Okay. And let's see. Debbie, did you tune in when I was going over the temperature stuff?
The beginning of it, I was writing it down. Where you were saying the freezing is 032, room 2276-1.
Yeah.
I didn't get that last one somehow. 102.12.
Yeah. So those are some good ones to know, to just have a baseline. When you see a Celsius temperature, you know, oh, that's hotter than water boiling, or oh, that's a little above room temperature, or that's
Okay.
about my human body temperature, things like that. Okay. Let's see, we're almost ready to do this. Let's check out problem 11 while they finish. Not coming out.
So 200 grams is too much. When you start sliding it back. Close.
All right, so and then number 11, greatest possible measurements. Okay. Greatest possible error. That's an interesting question. Well, I don't remember picking this question, nor do I have any idea
200 grams.
what it means.
100.
Give the greatest possible
So
error
I'm a little off.
Right, okay.
for each of these.
That's pretty good.
Huh. That is a weird question.
That's what I thought.
Yeah, it says it's like number 22 in the book. Let's look up the book. Chapter 11, section 2. Yeah, usually I screen each question, and I don't remember that one. see if the textbook shows it differently. Chapter 11, let's go to section 3 and back up. That was like section A. B. Okay, A22. Give the greatest possible error for each of the following measurements. That is strange. I have no idea.
Oh, the margin of error one?
Yeah. Let's see, what did they do earlier?
The feet have like a half. Oh gosh, I'm trying to remember it.
Yeah, I didn't mean to assign that one because
It goes respectively though, like like to the centimeters to the meters, and down the line, it's moving the decimal place. So like, I want to say, without looking at the problem, it was like 0.5 and 0.05 and then 0.005. Is what I remember from that problem.
I don't remember anything like that earlier in the book, though. Oh, here we go. Greatest possible error. We'll load that up.
It's bizarre line, but I've rolled with it.
What page is that on?
This is page 656 in the book.
Thank you.
Yeah.
It's 150, and it's at 100.
Okay, so they go over by a half of a unit either way.
Yeah. Yes, sir. All right.
Well, I thought it was a different 150. Yeah, that's just one of them.
Okay. So then for that problem, the greatest possible error for 3.58 centimeters, let's see, did it say to consider the decimal? It would be half a centimeter, I think.
Yeah.
Yeah. So they're just looking for us to go half of whatever the unit is, so 0.5, and they already give centimeters. Can't see what button that is. Sorry, that's not correct. 1/2 of the unit used.
Try 0.05.
Maybe it's going down to the decimal. Let's read that again. Oh, they go to the next place after that. So we have to consider place value too. So then here, since we have it to the nearest hundredth, we'd want to go to the thousandth. Let's see, 1.2, yeah. Oops, where we go? There it is. So it should be a 0.005. So then here, since we go to the nearest tenth, then we'd want to go one more decimal place to the nearest hundredth. So 0.05. I like the type of leading 0. Sorry, I did not want to assign this one. And here, since we're to the nearest foot, we would just go to the nearest half a foot. Oops.
Okay.
Fantastic! Okay, so let's go back to number 10. Number 10 requires a little bit more work. All right, you guys got the spun? No, you did. What was the last one? The marble grab.
So what are we squeezing into and what are we measuring the milliliters is?
So on that one, that is a good one. Use this. Oh, no, it says it on there. Okay, that's why.
We can just squeeze in the white one for.
Oh yeah, there you go. You can squeeze it up. So what you want to do is you want to. We don't want it to be too wet. It's got to fit in there after.
I'm going for that.
So you squeeze in there and then guess how many milliliters that is. So I'm going to guess. I'm going to guess 60. Guess that 80 milliliters. Let's see. Yeah, it's 48 milliliters. Okay, I'll do that. Hopefully you'll do better than me. Okay, so let's do this problem here. So let's see. We've got here, okay. Mach describes the speed. Mach 2 is twice the speed of sound, so Mach 1 is the speed of sound. So we've got, right now, 1.6 for the Mach. So I spelled that wrong. Mach. And so that means every Mach is 344 meters per second according to this. So we have 1.6 times 344 meters per second. That's where we're at now.
Okay.
And we want to convert that to kilometers per hour. So to do that, we have to eliminate meters, turn them to kilometers, eliminate seconds, turn them to hours. So how many meters are in a kilometer?
I don't know.
So that would be 1,000.
Okay.
Oh, you didn't get to see the chart I had on the board last time. Let me bring this up. Oh, let's see. Okay, let's see which day is the last class.
Oh, yeah.
And everything's measured in milliliters.
Sorry.
I said 80.
Let's see my notes here. Okay, I'll just have to rewrite it. So it's just slight diversion. Common metric measurements. You've got your kilometer, or let's see what's next. Hectometer. Uh-oh, that pen just died. Seriously? Can you still hear or see anything?
Yeah, I can see and hear, but it's not writing.
Oh, there we go.
Yeah.
Okay. So kilometer, hectometer, decameter, no, it's DA. Meter is in the middle, and then we have next decimeter, centimeter, and millimeter. And so it doesn't really matter whether it's meters, liters, or something else. Oops. What matters is the prefixes.
Okay.
And as you move through the chart, the order in which these are tell you how to move the decimal place. So if somebody says they have 1 kilometer, to convert that to meters, I would go 1, 2, 3 places in this sequence. So that means I should add 1, 2, 3 zeros to this that way. So that tells me that 1 kilometer is equal to 1 meter. If I went, if I started at a different spot, like somebody said they had 1,000 centimeters, and I wanted to convert that over to meters, that tells me to shift the decimal point twice to the left. So that would become 10 meters. So if I have the kilo, hecto, deca, whatever the base unit is, deci, centi, milli, if I have that order memorized, then I can easily convert back and forth
Okay.
by just sliding along that scale.
Okay, so the 1 kilometer, how should that really read? Because 1 is not going to be equal to 1, right?
Oh gosh, that was supposed to be in 1,000. Sorry. Yeah, so the chart here says that 1 kilometer
1,000. Okay, that's what I thought. I just wanted to make sure.
meters. Yeah, sorry about that. So there's a couple of ways to approach the conversion. One way to approach the conversion is to memorize this order and just slide back and forth. The
Okay.
others have a few conversions memorized. Like some people just memorize 1,000 meters, 1 kilometer. Or
Okay.
1 meter is equal to 100 centimeters. So those are the two most common ones. And so there's pros and cons to each version.
Okay.
Okay, so back to this problem. So knowing either that chart or the conversion factor allows me to come here and say that if I want to get rid of meters and convert to kilometers, then I would have to put 1,000 meters in the bottom or 1 kilometer in the top. So that allows me to get rid of meters.
Okay, so then we got to change the seconds to hours. Is that how it works?
Then we change the seconds to hours, and we could take that in stages by saying there are 60 seconds.
One had
in the minutes,
425 on the cotton ball.
Oh,
I said
and then
900
there are 60
centimeters.
minutes
right.
475.
in 1
My
hour.
biggest one was 230 for that discus thing out there.
And so what I've collected then are a series of conversions that cancel units until I
One of
finally
them I
end
have
up
at
with
like 9,
kilometers
the other
per
one was
hour.
620 off.
So this tells me to take my product of the Mach times the speed of sound,
1 degree on the other.
divide by 1,000, multiply by 60, and multiply by
Jack was
60,
one that's dropping
and that should make the conversion.
Red gas. Right.
Okay.
Does that make sense?
I think so.
Yeah. So it's using conversion factors that we were playing with when we were doing the ratio and proportion stuff back in Math 112, but combining it, 212, excuse me, but combining it with the metric system now.
Okay. I will try that and see if it works.
Yeah, that should work out fine. Okay, so homework problems aside, you guys need to try to do the metric stuff as best you can over the next couple of days, and then send me whatever results you have. If there was stuff you couldn't do because you couldn't find the resources, like a scale that does grams or a thermometer that does Celsius to do the temperature trials, or the
I think I would see the temperature trials and just convert it.
oh yeah, you could just do it. Well, no, that misses the point. So Greg said do the temperature trials and convert it. Yeah, the point is to just kind of try and play and think in Celsius, or to think in grams, instead of doing it in whatever system you're familiar with and then translating. And the hope is, like, if we repeatedly did this all the time, we would just be used to that system. You know, you're used to walking in the room and saying, boy, it's cold in here. It must be 19 degrees Celsius. Or, man, it's too hot in here. It must be 25 degrees Celsius. Somebody change the heat. Just getting used to those ideas is what we want to do. And the Metric Olympics gives us a chance to play around with that a little bit. So, like with kids, this would be something you could do some of these events a few times over the year and see if maybe they get better by the end of the year in estimating. And then we'll then do a final comparison of whatever events everybody could do to see who's the winner in the common events. And so we'll have prizes. So please do what you can for Wednesday, and then we'll come back and see what happens. Usually I play too. I didn't have time today, and I don't usually win though. There's usually a student that beats me. So that's pretty cool. I wouldn't get a prize anyway though. All right. So that's it for today.
All right. Thank you.
Yeah, have fun, do metric stuff. And again, you don't necessarily have to throw a cotton ball. The point is to throw something light so it doesn't go very far. Like Greg, who tried to throw it across the room and succeeded. All right, thanks. You guys have fun. And as of Wednesday, we'll have some other new stuff to do besides this.
Okay, and remember Wednesday is when I have to meet with Miriam Monk.
Okay. Yeah, so if that doesn't go too long, stop by after so you can say hi.
I will.
All right, and then I'll let you borrow some marbles.
Perfect.
All right, Kelly and I will see you Wednesday.
Uh-huh.
Excellent. Okay. All right.
I will be a little bit late, but I will be there.
Okay. We'll be looking for you with your metric stuff.
Okay.
All right. Bye-bye. Yes?
Is there any way to borrow something tomorrow? Because I will be there all day tomorrow.
Yeah, I'll be around. Just stop by. I'll have this stuff out in my conference room by my office.
Okay. Bye.
All right. Bye-bye. All right. Who won?